Alright guys, today we're starting with lesson 3, that is raising an exponent and exponential notation to a different power. But before we get into that, I want to go over a little review of repeated addition and what happens whenever we have it in this certain form. So I have 3 plus 3 plus 3 plus 3 over and over and over again. This is repeated addition, right? But let's look, I have it separated into parentheses. So inside this parentheses, I have 3 plus 3 plus 3 plus 3. Now, that we know is repeated addition, which is also what? Multiplication. So if I have 3 repeated, and I have it repeated of four times, then it is 3 times 4. And the same thing goes over here. This is all 3 plus 3 plus 3 plus 3. So this is 3 times 4 in this bracket, plus another 3 times 4, plus another 3 times 4, plus another 3 times 4, plus another 3 times 4. Now, some of you might think we're done, but we can actually simplify this in even further. How can we? I have repeated addition again, right? This is 3 times 4 plus 3 times 4 plus 3 times 4 plus 3 times 4 plus 3 times 4. What that's saying is I have one group of a thing called 3 times 4, and I'm adding it to itself a certain amount of times. And we know that when you add something to itself over and over, it's just multiplication. So that means I have 3 times 4 as a unit being multiplied a total of 1, 2, 3, 4, 5 times. So this is how you simplify this down. And the reason I'm showing you this is because it is almost the same thing whenever you have something like 3 to the 4th power raised to the 5th power. Now it's going to look a little bit scary to you if you've never seen it before, and I don't think you have. So what does this mean? This is an exponential notation, 3 to the 4th power raised to the 5th power. Remember what we said about exponential notation. It's just repeated what? It's repeated multiplication. So let's look at 3 to the 4th power first. What 3 to the 4th power is just 3 times ... 3, a total of how many times? A total of 4 times, right? So 3, and I know I could have just wrote 3 times 3 times 3 times 3, but I'm doing this for a reason. So you have 3 times 3 times 3 times 3 for a total of 4 times. And that looks like, remember, 3 times 3 times 3 times 3. This is 3 to the 4th power. Now, this notation says I have 3 to the 4th power to the 5th power. Let's say this wasn't here, this exponent wasn't there. What does 3 to the 5th power mean? Well, that means everything I have in my parentheses, that 3, that is being multiplied by itself 5 times, a total of 5 times. So even if I put this parentheses back, I have 3 to the 4th power to the 5th power. That means I have 3 to the 4th power being multiplied by itself 5 times. What that looks like is, remember, 3 times 3 times 3 times 3 is 3 to the 4th power. I'm going to multiply that again by 3 times 3 times 3 times 3. So this is 3 to the 4th power times 3 to the 4th power again. A total of how many times do y'all think? It's a total of 5 times. What this means is, and how I can simplify this is, I have 3 times 3 times 3 times 3. So this is 3 times 3, a total of 4 times. So that means I have 3 being multiplied 4 times. And then that 3 to the 4th power is being multiplied another 5 times. All of this was to show you that I have 3 to the 4th power, And anytime you have an exponential notation being raised to another power, all that means is you have your exponent, the 3 to the 4th power, being multiplied by itself another 5 times. So if you have 3 to the 4th power to the 5th power, it's the same thing as saying I have 3 to the 4th power times the 5th power. So instead of 3 to the 4th power raised again, you can simply say I have 3 to the 4 times 5, which is what? The 20th power. And if you don't believe me that works, that method always works. I know this because I said 3 times 3 to the 4th power was 3 times 3 times 3 times 3. That's 3 to the 4th power. And it happens a total of 5 times. That would be 3, 3, 3 times 3. That's the second time, times 3, times 3, times 3, times 3. Third time, times 3, times 3, times 3. Fourth, and if you count all of those threes, I have 3 to the 4th power right here, 3 to the 4th, 3 to the 4th, 3 to the 4th, 3 to the 4th, a total of 5 times. And if you count all of my threes, then that is 20 threes. And I know if I have repeated multiplication, it's 3 to the 20th power. So if you have 3 to the 7th power to the 3rd, all you have is 3 to the 7 times 3. If you have 2 to the 2nd power to the 4th power, then you have 2 to the 2nd power times 4. Now let's begin working on our exercises. Go ahead and pause this video, start working on exercise 1 through 6, and see if you can kind of figure it out. Unpause it whenever you're ready. Alright, so I have 15 to the 3rd power raised to the 9th power. I know that I have an exponential form raised to the 9th power. This is the same thing as saying 15 to the 3rd power times the 9th power. 3.4 to the 17th power raised to the 4th power. I have 3.4 to the 17th power times 4, the 4th power. I have negative 2 in parentheses for a reason, remember that. Negative 2 to the 5th power raised to the 8th power, it's just multiplied by 8. And then I have let s be a number to the 17th power, so I have s to the 17th power raised to the 4th power. I have 17 times 4. Exercise 5. Sarah wrote 3 to the 5th power raised to the 7th power equals 3 to the 12th power. Correct her mistake. Write an exponential expression using base of 3 and exponents of 5 and 7 and 12 that would make her answer correct. So what did you notice that she did wrong right away? Well, she did 3 to the 5th power to the 7th power should equal 3 to the 12th. Why do we know that's wrong? Because I just said if you have an exponential notation raised to the 7th raised to any other power, it should be 3 to the 5th power times 7. So it's 3 to the 35th power. So she didn't do that right, or she has the wrong answer to a different problem. The right answer to a different problem, sorry. It wants you to write an expression using a base of 3 and the exponents of 5, 7, and 12 that would make her answer correct. They don't want you to change they don't want you to make her answer correct. They don't want you to change her answer. They want you to keep her answer the same, but change the problem so that her answer makes sense. So, instead of having 3 to the 5th power raised to the 7, I still need to use the exponents 5, 7, and 12. And how I can do that is, I know that 12 is going to have to be used in her answer because she said her answer was 3 to the 12th power. So I already used my 12th exponent, and that this has to be her answer. What can I do to make her answer correct? If I have 3 to a certain power, let's make it 5, and I have 3 to the 7th power. What can I do to these two to make this correct? If you remember from our last lesson, if you have two numbers, 3 to the 5th power, some type of operation 3 to the 7th power, we'll be able to add those two exponents together. And what was it? Remember, if I have 3 to the 2nd power times 3 to the 2nd power, I just add those exponents together, because 3 to the 2nd power is 3 times 3, times 3 to the 2nd power is 3 times 3. So I would get 3 to the 4th power. Same thing happens here. If I multiply this, I would get 3 to the 5th power times 3 to the 7th power. If I add 5 and 7 together, I get 12. Now, exercise 6 is a little tricky. I have the number y satisfies this equation. Satisfy means it makes it true. That y to the 24th power minus 256 equals 0. What equation does the number x satisfy? So they want you to use the same equation, but use x. And it tells you that x equals y to the 4th power. Now, if x equals y to the 4th power, and I know that over here x is going to replace y to the 24th. Y to the 24th is going to go away, and I need something that says something of x minus 256 equals 0. I need to find an x value that makes it true. I can't put just a plain x right here because x equals y to the 4th. I need x to replace y to the 24th. So how can I make x equal y to the 24th? What can I do? Well, I need to make y to the 4th power equal 24. How can I do that? I can take x, raise it to the 6th power, and remember how exponents work. How equations work. If I do something to this side, I have to do it to this side. So if I take y to the 4th power, raise it to the 6th power, what happens there? Well, this is an exponent raised to another exponent, which means I have y to the 4th times the 6th power, which makes it equal y to the 24th power. And that means I can rewrite this equation over here that was y to the 24th minus 256 equals 0. Then I have, if I wanted to use x, it would be x to the 6th power, because remember, x to the 6th power is y to the 24th, minus 256 equals 0. All right, we're going to go back to another discussion before we move on to the next set of equations, of exercises. It tells you that xy to the n power equals x to the n times y to the n. And I'm going to explain why that's true. So, if I have, let's say 5 times 8, and I raise that to the 3rd power. 5 times 8 to the 3rd power. How can I make this expanded form? Well, I know that this exponent means I repeat multiplication, so I have 5 times 8 times 5 times 8 times 5 times 8, right? Can I simplify this? Since it's commutative property, everything's being multiplied, I can take away those parentheses and just have 5 times 8 times 5 times 8 times 5 times 8. So let's do that. And then I can rewrite it to where I have all of my numbers right by themselves. So I have 5 times 5 times 5. I can do this because of commutative property. Times 8 times 8 times 8. And I know about exponential notation. I have 5 times itself 3 times. This can equal 5 to the 3rd power times 8 to the 3rd power. So is it true? If I have x times y, remember, if I have two x variables by themselves, it means multiplication. X times y, in this case 5 is my x, times a y of 8, equal to an n exponent, which in this case is 3, equals the same thing as saying x to the n times y to the n. Is that true? Absolutely. And this works for every time, including if I have something like this. Let's say I have x over y to the third power. Does this equal, does this exponent go to each number? Let's see. What does x over y to the third power means? It means I have a repeated multiplication of x over y times x over y times x over y. And I know about multiplying fractions. I just go across and multiply. This is x times x times x over y times y times y. I can simplify this. This is repeated multiplication. I have x to the third power over y to the third power. So if I have two different variables being multiplied or divided by themselves in an exponential problem, that exponent just goes to each of the variables. However, whenever I have something like this, x plus y to the third power, does that equal x to the third plus y to the third? Answer is no, because it's multiplication. It's because it's addition. If I were to change that to x plus y plus x plus y plus x plus y, and I'm doing that because it's an exponent, this is not the same as simplifying it to x to the third plus y to the third, because it's repeated addition. What do we know about repeated addition? That is multiplication. I have 3 x's, so that is the same thing as 3 times x, which we know we can write as this. And I have a total of 1, 2, 3 y's, which is 3 times y. So if you have x plus y to the third power, it does not equal 3 to the x to the third plus y to the third. Same thing goes for x minus y for the same reasons. It does not equal x to the third power minus y to the third power. You would have something like this. I didn't work it out, but it would still be multiplication because that will be repeated addition. If it's multiplication or division inside, your exponents will scatter out, but in this case, they will not. Knowing that, go ahead and work the next few exercises. Pause the video and unpause it when you're ready. All right, so we have x times 4 to the 9th power. It's multiplication, so I know I can say it is 11 to the 9th power times 4 to the 9th power. Let x be a number. 5 times x to the 7th power. Now remember, this is 5 times x. Those are two different numbers. So I have 5 to the 7th power times x to the 7th power. If you want to simplify them, you can. Right now, I'm just showing you how to do this. 3 to the 2nd power times 7 to the 4th power raised to the 5th power. What does that mean? It means, like I said, since it's multiplication, this exponent gets distributed to each one. And because it's a notation, an exponential notation being raised to the 5th power, then I have 3 to the 2nd power times that 5. And then I have it multiplied by 7 to the 4th power times that 5. Let x and y be numbers. 5 times x times y squared raised to the 7th. Then I have 5 to the 7th power. Because, and the reason I'm not specifically multiplying right here is because remember, when you have a number like 5 and there's no exponent, they always have an exponent of 1. But 5 multiplied by itself one time is just 5. So I could say I have 5 1 times 7, but it would just be 5 to the 7th power. See what I'm saying? So 5 to the 7th power times x, same thing goes for x, it's 1 times 7, but I can just say 7, times y squared times 7. 3 squared times a to the 4th times 5. So I have 3 squared times 5 times a to the 4th times 5. A squared times b times c to the 3rd power. Raise all of it raised to the 4th. I have a to the 2nd power times 4 times b to the 4th power times c to the 3rd power times 4. Exercise 13, let x and y be numbers. Y does not equal 0, and let the n be a positive integer. How is x over y to the n power related to x, n, and y? And y to the n power. Remember what I said earlier. Whenever you have x to the y to any power, I'll say 2. It's related to xn and yn because whenever you expand it, it is x over y times x over y, which will make it equal x to the 2nd, or x to the n, divided by y to the 2nd, or y to the n. That's how they relate. All right, you guys go ahead and start on your problem set. Make sure you send those to me and do the rest of your work in Google Classroom, and I'll see you for the next lesson.